Hey everyone, so I was recently searching on Google to buy an FPGA board and I came across this interesting one, the Kria KV260 Vision AI Starter Kit by AMD Xilinx. At first, I was really curious, but when I looked at the specifications, I was honestly struck. There were so many terms I did not understand. System logic cells, DSP slices, QSPI memory, it all looked confusing. So I decided to study and figure out what each of these specifications actually means. And in this video, I will share everything I learned in simple and easy words. Let's go through them one by one in the exact order they are mentioned in the specification sheet. Thermal cooling solution. This means the board uses active cooling, not just a heat sink. It has a small fan to maintain temperature when the FPGA is doing heavy tasks like image recognition or AI interference. Active cooling helps prevent overheating, which keeps performance stable and extends the board's lifespan. Weight. The whole kit weighs about 205 grams, which is pretty lightweight for such a powerful device. You can easily carry it around or mount it in a small enclosures, perfect for edge AI or robotics projects. Form factor. This board is made up of two parts. SOM, system on module. This is like the brain, it contains the processor, memory and FPGA chip. Carrier card. This is like the body. It provides the connectors for USB, HDMI, Ethernet and cameras. This modular design makes it easy to upgrade or replace just one part without changing the whole system. Dimensions of the KV260 starter kit. This is the size of the entire kit, small and compact, roughly the size of your hand. It's ideal for desktop use, prototyping, or embedding in a small device. Dimensions of the SOM with the thermal solution. This refers to the SOM only, including its cooling system. It's small, packed with components like FPGA, CPU, RAM, and security features. You can even detach it from the carrier card and use it independently in your own hardware design. Dimensions of the carrier card. This part hosts all the I/O ports, camera connectors, display ports, and power supply pins. It's designed to make development easy. You just plug in your peripherals and start working. System logic cells. These are the programmable building blocks of the FPGA. The higher the numbers, the more complex circuits you can implement. With 256,000 logic cells, you can design high performance algorithms for AI, image processing, or custom digital logic. Block RAM blocks. These are small chunks of memory located inside the FPGA. They store temporary data during processing like variables, buffers, or lookup tables. More block RAM means the FPGA can handle bigger data operations efficiently. Ultra RAM blocks. Ultra RAM is a larger and faster memory inside the FPGA. It's used for big data storage within the chip. It helps improve performance in data heavy tasks like AI interference or image processing. DSP slices. DSP stands for Digital Signal Processing. These slices are specialized hardware blocks that perform math operations like multiply and add extremely fast. With 1200 DSP slices, this board is excellent for AI, audio, and video applications that need real time number crunching. Ethernet interface. This means the board supports gigabit Ethernet, allowing fast data transfer over networks. Perfect for connecting to the local network, edge server, or cloud for AI data streaming. DDR memory. This is the main system memory similar to the RAM in your PC. It stores data that your applications use while running. 4 GB is quite good for running AI models, video processing, or Linux based systems smoothly. Primary boot memory. This is a small flash memory that stores the boot files. Basically, it helps the system start up. QSPI stands for Quad Serial Peripheral Interface, a high speed way to store firmware or OS images. Secondary boot memory. If you need extra space or want to boot from a different OS, you can use a micro SD card. This is commonly used to load Linux or custom applications. Device security. The board has strong inbuilt security. Hardware root of trust ensures only verified software runs on boot, protecting from tampering. Infineon TPM 2.0 adds another layer of protection by storing cryptographic keys safely and enabling measured boot for trust validation. This makes it ideal for industrial or AI edge systems where data security is critical. Image sensor processor. This inbuilt ISP helps process camera input in real time. It can handle up to 13 megapixel image sensors, adjusting color, brightness, and sharpness before the data reaches the FPGA or CPU. That's perfect for computer vision and AI camera projects. IAS MPI sensor interfaces. These are camera input connectors. You can attach up to two MPI cameras for stereo and multi-angle vision. It's great for depth estimation, robotics, or traffic monitoring applications. Raspberry Pi camera interface. This means you can also plug in a Raspberry Pi compatible camera module directly, making experimentation easy if you already have PI cameras. PMOD 12 pin interface. The PMOD connectors lets you attach external sensors or modules like ultrasonic sensors, temperature sensors, or motor drives. It's a flexible way to expand the board's functionality. USB 3.0 interface. You get four high-speed USB ports for connecting peripherals like keyboards, USB drives, or even cameras. USB 3.0 means fast data transfer, which is important for AI model input or output. DisplayPort 1.2a. You can connect a high resolution monitor directly to view processed video or run a graphical user interface. DisplayPort supports 4K video output, which is great for vision demos. HDMI 1.4. And finally, there is an HDMI port, another option to connect displays. It supports up to full HD resolution, ideal for real-time video output from your FPGA or AI model. So that's the full breakdown of Kria KV260 Vision AI Starter Kit. Every single specification explained in simple terms. When I first read the list, it looked confusing, but once I understood what each line meant, I realized how powerful and flexible this board is. Perfect for AI, vision, and embedded system projects. Well, thank you for watching this video.